Hello, and welcome to this video on writing equations of polynomial functions when given their graphs. I'm going to demonstrate this for this graph here. This process makes use of the corollary to the fundamental theorem of algebra, which in shorthand is written here. It says that any polynomial function can be written of the form y equals a times a quantity x minus r1 times a quantity x minus r2 times a quantity x minus r3, and so on and so forth up until the final known root. Okay, so what this means when you look at it is that this expression is variable in length, so to speak. Okay, and it depends on the number of roots you have. So here where we have 3 roots, okay, you'll see that I'll go up to R3. Okay, if it had 2 roots, you would use this portion. Okay, if it had 6 roots, you would be using 6 of these factors. So that's what that notation means. I always get a lot of questions about what the dot, dot, dot means. RZ just means I don't know the number of roots that I'm going to be dealing with in any particular problem. It could vary from problem to problem, but once you're given the problem, you can tell quickly by looking at the graph that we have 3 roots here. Okay? So I'm going to break in the middle of this problem to sort of go to a demo so that the concept makes sense, and then come back and finish the problem. So this is what we see here. The first thing I'm going to do here is make a quick chart, okay, of the roots. It's going to say R1, R2, R3. Okay, we have that R1 is -4, R2 is -2, and R3 is 1. Okay, now, right from this next part, you're actually going to really be more than halfway to the problem being completed. Okay, so we're going to take a look here and we're going to say y equals a times a quantity x minus -4 times a quantity x minus -2 times a quantity x minus 1. Okay? Now, the only thing that is stopping you from multiplying all of this out and knowing the exact answer is that you don't know a yet. Okay? So, I'm going to take a little bit of a break and make sure that you understand the larger concept here, and then I'm going to come back and finish this problem. Okay? Let me go to this Sketchpad demo for just a second. Now, if you notice here, I have a function that has the same roots that we just talked about in the chart I made. Okay? And here they are. And I've graphed this function in a way that a is a variable idea. So here, I'm going to actually use the Sketchpad demo to animate the a value in the function. If you notice, you should be looking right here and seeing it's changing. Now, one thing you need to realize here is that the roots are not changing. Okay? So, if you notice here, on the graph, the roots don't change, but the graph changes because the a value changes continually. So again, I'm trying to reiterate that you just have to be able to find the right a value to be able to complete the problem that we're showing on the other page. So let me stop the animation and go back to that. Okay? So the question here now, again, is how are we going to find that a value? Well, the trick is that you can use any point on the graph that you know other than a root and plug it into this equation. And when I do, I think you're going to see what's going to happen here, that you're going to be able to find a. So the thing I need to do is look on the equation for look on the graph for a particular point that I know. And I'm going to pick this point right here. Okay? Because I definitely know that it's hitting that grid, and that point is 2, 6. So that's the x and the y. Okay? So now, I'm going to take a second and rewrite this problem, but I'm going to plug in x and y, and then you're going to see that finding a is going to be pretty easy. Okay? So y is equal to 6, equal to, I don't know a, now I've got x, which is 2 I'm going to start simplifying a little bit with my signs here. Plus 4, plugging in for x again, 2, plus 2. Again, always making respect of saying times a quantity when I'm reading, at least in my head, right? And then I'm going to plug in my 2 again, and then minus 1. So now you see that given that information of knowing the roots and knowing a point on the curve, I've now created an equation in one variable. So this should be pretty easy to solve here. We get 6 equals a times 6 times 4 times 1, which gives me 6 is equal to 24a. A is equal to 6 divided by 24, which is 0.25 or a quarter. Okay? Now, we said once we found A, we can plug it in back here and be able to write the final equation. So, to write this in polynomial form, I'm going to have to FOIL it out though. Okay? So what we have here, we've got y equals 0.25 times a quantity, x plus 4, times a quantity, x plus 2, times a quantity, x minus 1. Okay? Now, this is the equation of the graph, but it's not in polynomial form, so you're just going to have to multiply it out. So to do that, I'm going to start multiplying on this end first, okay? And then I'll multiply the x plus 4 factor and then distribute in the quarter in a second. So we've got y equals 0.25 times x plus 4. And I'll do this part in color here. So now we've got x squared, negative x plus 2x minus 2, right? Then I'll clean up a little bit of my like terms. X squared plus x minus 2. Okay, and now I'm going to multiply here. Okay, and that's going to give me y equals 0.25 times x cubed plus x squared minus 2x plus 4x squared plus 4x minus 8. Okay, I'll clean up a little bit of my like terms and say x cubed plus 5x squared plus 2x minus 8. And now I'll finally distribute in the quarter and get 0.25x cubed plus a quarter of 5 is 5 quarters, x squared. A quarter of 2 is a half, right? So now I get a half x, and then a quarter of 8 is 2, which is negative. This equation, again, although equal to this one that I'm pointing at, is the final answer because you are asked to write a polynomial function. We see we've gotten a cubic, which jives with our notion of the fact that there were 3 real roots, and it's written in descending order, which is nice, and that's the final answer. Okay, so let me give you a quick overview again of what happened here, okay, in terms of steps. Okay, so step 1 was to make a quick chart of the root values, okay? Step 2 was to plug those values into the corollary to the fundamental theorem of algebra, which states that you can write any polynomial function when you're given the roots in that form. Okay? Step 3 then was to plug in a point from the curve so that you create an equation in one variable, and that one variable is a. Again, we said the whole trick is to know the right a value. Okay? I'll come back to that in a second. Okay? Solve that equation, and then plug that value back into the original, and then multiply out appropriately, giving us a polynomial. Okay? Now, to check this out, I'm going to go back to the demo. If you notice here that I actually put that 2,6 point there, and then I guess it's just a matter of me making the a value to be 0.25. I'll try and get it as close as I can because of the way this demo rounds might not be available to me. And it does, and when I make a 0.25, I get an exact replica on this computer demo as that I had here in this graph. So I hope that's a help. Enjoy. practice, feel free to share.